Hello guys, welcome once more to another video in our YouTube channel. So in this video we are going to be looking at the topic conic sections, and we are going to be solving June 2021 further math paper 2 question 5. It came in the topic and a total of 6 points. Okay, it reads, show that a curve with polar coordinates r theta, where r is equal to this, theta different from this for all n, the set of integers, is a parabola p in the xy plane. Show that a point 034 lies on P and find the equation of the tangent to P at this point. Alright, so before I begin with the equation, I'm just going to demonstrate to you guys how to change from the polar plane to the Cartesian plane, because this question we just need to change this polar equation to an equation in the xy plane, and then we verify. We will see if it takes the exact form of a parabola, and then we conclude. Alright, so generally, for example, if I take, maybe I just take, let's just take the xy plane, 0 y, and here is x. Now if I have any point for a, maybe I just take a curve. I'm just giving an example, and then I have a point on this curve. Yes, now let's say we are here's the horizontal axis, here's the vertical axis. The point P here has coordinates r theta. Yes, now this distance from the origin right up to the point P on our curve. Now the distance, the horizontal distance is let's take generally x. Yes, let's take x and y for example. Now the angle that distance or that length makes with the horizontal axis is our theta. Now let's just say the horizontal distance is x and the vertical distance is y. Okay, so we need to get the relationship between x and y with r and theta. So since this is a right angle triangle, as we can see, right, means that if you use SOHCAHTOA, or if you use SOHCAHTOA, if you take the sine of theta, you're going to get what? The opposite divided by the hypotenuse. That's the sine of theta. So sine theta is equal to opposite, which is the vertical distance, which is y, divided by the hypotenuse. So what do we see? We see that our y is equal to r sine theta. Okay, what about if we take the cosine of theta? The cosine of theta is the adjacent, which is x, divided by the hypotenuse, which is r. So what does it mean? It means that our x is equal to r times the cosine of theta. So that's the relationship between x and y with r and theta. So with this, we can be able to change from the Cartesian coordinate system to the polar coordinate system, and from the polar coordinate system to the Cartesian polar coordinate system without any difficulty. So let's get back to our equation. So we are going to convert this equation to an equation in the Cartesian plane. Alright, so our equation is r equal to 3 divided by 4 cos theta plus 4. So this is our equation. We have r is equal to 3 divided by 4 cos theta plus 4. The domain of definition, theta is different from 2n plus 1 pi, where n is an integer. Alright, so here we are going to have r is equal to so that's my parabola P. R will be equal to 3 divided by 4 is a factor in the denominator. We get cos theta plus 1. Okay, so my parabola P, r will be equal to 3 divided by 4, 1 divided by, what's the value of cos theta? Cos theta is x divided by r, x divided by r plus 1. Remember, we need to change everything, all the arrows and the functions in theta to be in x and y. So with that said, our r will be equal to 3 divided by 4 into 1 divided by, now the LCM here is r, so we get x plus r then divided by r. Okay, so our parabola P is going to be r is equal to 3 divided by 4. Now the r in the denominator here is going to go to the numerator, so you have r divided by x plus r. Now clearly r is going to cancel with r because r can never be 0 since it is a distance. Alright, so my parabola p will be defined by 1 is equal to 3 divided by 4 times 1 by x plus r. Alright, now I can do a little bit of gymnastics. We can multiply and then we see what we get. So our parabola p given by 4 is equal to 3 divided by x r. 4 is equal to 3 divided by x plus r. Okay, that's from this step here, right? I cross multiply with 4. Anyways, we are also going to send this denominator to this side here. Okay, so our parabola p will be defined by 4 into x plus r to be equal to 3. So our parabola p, we have 4x is equal to 3 minus or 4r, sorry, let's keep r in one side. 4r is equal to 3 minus 4x, because here you have 4x plus 4r, right? Okay, now what's my essence of doing that? I know that this vertical distance here is y and the horizontal distance is x. Since it's a right angle triangle, it means that what the square of the longest side is equal to the sum of the squares of the other two sides. So r squared will be equal to x squared plus y squared. Okay, so with that said, I can square both sides in this case because I don't need r in my equation, because I need to convert everything to be in the x and y. So if I square both sides, I will get 16r squared to be equal to 3 minus 4x, then all that squared. So my parabola p 16, where was r squared, is x squared plus y squared. Now when you square this side, you have 9 minus 20x plus 16x squared. Alright, so with that said, our parabola p, if you expand this side, you get 16x squared plus 16y squared to be equal to 9 minus 24x plus 16x squared. Okay, so we see 16x squared cancels from both sides, and then now we get our parabola p to be 16y squared equal to 9 minus 24x. Now we can divide all through by 16. Okay, we can divide all through by 16. Dividing all through by 16, right, we are going to get y squared to be equal to 9 divided by 16 minus 24 divided by 16 times x. And clearly this is the equation of a parabola. So that's the equation of a parabola. Okay, so the next part of the equation, so we have shown that this is a parabola. That should require a full lesson on conic sections is going to be done, so you're going to know how to identify the equations of all the conic sections, be it a hyperbola or be it an ellipse or be it a circle. Alright, so we have shown that it's a parabola in the xy plane. Now the next is that we should show that the point 0, 34 lies on p, and then we find the equation of the tangent to p at this point. So so next is that we have to show that the point 034 lies on p. That's the first thing. Now if the point 034 lies on p, right, what does it mean? It means that if I substitute the y coordinate, because on this plane, right, the point x and y lies on this parabola. So if I replace x with 0 and y with 3 on 4, and then I'm trying to show that it lies on p, it means that all I need to do is I need to replace the value of y here, and then I replace the value of x, and then I compare the two sides of the equation. If the two sides are the same, then I can conclude that yes, the equation, the point this lies. So the point 034, right, I replace the value of y with 3 divided by 4, and then I will need to square it. Should be equal to 9 divided by 16 minus 24 divided by 16 times 0. This is x, and then in 0 here is y. Remember that here we need to square the y. Okay, so this means that here is 9 divided by 16 is equal to 9 divided by 16. Hence the point 034 lies on P. Why? Because the 9 divided by 16 is equal to 9 divided by 16. All right, now next we need to find the equation of a tangent to P at this point. So we are going to see the equation of a tangent to P at this point. Now our point is 0.